Welcome to this explainer. Today we're diving into a strategic masterclass on Cambridge AS and A-level information technology. Specifically, we're looking at section 1.4, which covers parity checks, checksums, hash totals, and control totals. Now we're treating this explainer as a very special edition, the Engineering Lab, Computer Science Cambridge Exam Strategy. Our core mission today is simple but incredibly powerful. We are going to build bulletproof arguments with stress-tested evidence and ironclad quality control. I want you to imagine, for just a second, that you're sitting in the exam hall. The clock is ticking. You open a real Cambridge Computer Science pass paper. Maybe it's syllabus code 0417, 0478, 2210, 9618, or the 9626 paper we're heavily focusing on today. I want to paint a vivid picture of two very typical students taking this exact paper. Let's call them Alex and Sam. Alex is the memorizer. Alex has spent weeks literally memorizing the textbook cover to cover. When faced with a complex question on verification methods, Alex goes into overdrive, overloading the answer with raw computer science facts. We're talking massive paragraphs of definitions, historical context, you name it. But here's the problem. There's absolutely zero critical analysis. None. Then there's Sam. Sam feels the immense pressure of that exam clock, panics slightly, and rushes through the paper. Sam completely misses these specific requirements of the command words. Sam might understand the underlying technology perfectly, but by ignoring the command words, Sam leaks massive amounts of marks. If we were to pull their exam papers right now and look at their flawed answers side by side with the senior examiner's red pen marks, it would be an absolute bloodbath. Red ink everywhere, good knowledge, terrible execution. Today, we are going to fix exactly that permanently. Let's start with this massive warning right from the examiners themselves. This highlights exactly why we need to build a bulletproof exam strategy today. Listen to this. Examiners report that 1.4 verification methods is one of the most misunderstood areas in information technology. This isn't just some casual observation thrown into a document. It is a recurring, glaring red flag in the Cambridge Principal Examiner reports year after year. Students exactly like Alex and Sam walk into the exam hall genuinely thinking that knowing the definition of an even parity bit, or maybe knowing how a basic checksum calculation works, is going to be enough to secure the top grade. But the examiners are telling us loudly and clearly that knowing the theory is only about 20% of the actual battle. The other 80%, it's how you apply, how you structure, and how you verify that knowledge within the rigid, uncompromising framework of a Cambridge exam paper. Today, we're going to decode the exact expectations of these examiners so you can transform all those red pen corrections into solid green checkmarks. Here's our roadmap to exam mastery today. First, we'll tackle the verification challenge. Second, the core theoretical principles. Third, the procedural framework. And finally, evaluation and examiner insights. Let's kick things off with Section 1, the verification challenge, learning from principal examiner reports. What's absolutely fascinating about these top 3 examiner warnings is that they aren't about a lack of technical knowledge. They are entirely about a failure in methodology and attention to detail. Look at the first 2, forgetting proper format and failing to check presentation. These are massive, easily avoidable pitfalls. When the exam asks you to demonstrate a hash total calculation or a modulo 11 checksum, you literally cannot just scribble a bunch of random numbers on the page and hope the examiner figures out your logic. If you don't lay out the data structure properly, you lose the marks. It's that brutal. And then there's the third warning, providing generic answers. This is Alex's fatal flaw that we talked about earlier. If the question specifically asks how a hospital uses a parity check for transmitting highly sensitive patient records, and you just write down a generic textbook definition of a parity byte without once mentioning medical data transmission, the examiner will heavily penalize you. Context is absolutely king. Before we continue, subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Core Theoretical Principles, building the foundation for verification methods. Now, the crucial point on this slide is that Cambridge examiners prioritize deep, systematic analysis over just memorizing a wide, superficial list of terms. They want logical, structured reasoning. To help you achieve this true analytical depth, I want to introduce you to the PEAL framework. It is a highly effective, absolute game changer for structuring your computer science answers. PEAL stands for Point, Evidence, Explanation, Link. Let's see this in action. Say you are asked to evaluate a control total in a corporate payroll system. Your point is explicitly identifying the method. Your evidence is extracting the specific wage data directly from the exam prompt. Your explanation is detailing exactly how the sum of the wages is calculated before and after the processing phase. And finally, your link. This is the magic step. You must state exactly why this specific method catches transposition errors in this specific payroll context. Our friend Sam missed this entirely by rushing the command words. If the command word on the paper is evaluate and your answer only manages to describe, you are forever stuck on the right side of the slide in superficial breadth, and your grade will reflect that.
This is a secret weapon that top-tier students use. You absolutely must treat these concepts, like checksums and control totals, as integrated parts of the whole IT syllabus, rather than just isolated, floating ideas. Think about it for a second. A parity check isn't just a neat little mathematical trick. It's deeply connected to network topologies, data packet transmission, and hardware reliability. A hash total isn't just a random addition of account numbers. It connects directly to database security and the efficiency of batch processing. When you are writing out your Peel paragraph, linking your explanation to these broader computer science concepts is exactly how you signal to the examiner that you possess true mastery over the subject. You are showing them that you understand the entire living ecosystem of information technology, not just a single flashcard you memorized the night before. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's get into the mechanics of this in Section 3, the procedural framework, the step-by-step methodology.
We are going to treat this part like an interactive workshop. Let's walk through this standardized sequence, which is your blueprint for logically processing data when you're dealing with something complex like parity checks or hash totals. Step 1. Identify the key elements of the scenario. What are we actually looking at? Step 2. Apply the relevant principles. Are we hunting for an odd parity error, or are we dealing with a corrupted checksum? Step 3. Execute the analysis with clear, step-by-step mathematical or logical working. Show your thinking. Step 4. Verify your own results before moving on. Check your own work. And Step 5. Present it all in the appropriate format requested by the command word. I want you to imagine a 60-second timer on your screen right now. If I challenged you to rewrite one of Alex's flawed, overly fact-heavy paragraphs using just these 5 steps, the transformation in your mark potential would literally jump from 20% to 100% almost instantly. This sequence forces you to be analytical.
Let's see how this standardized sequence builds directly into the specific mechanics of the exam hall. When you finally flip open that exam paper, this specific deconstruction process is exactly how top-performing students extract the core trends from incredibly complex texts and data tables. Take extracting relevant data, for example. In a rigorous 9626 paper, you might be suddenly faced with a massive table of hex values or dense binary sequences. You absolutely cannot panic. You use this framework. You extract only the bytes that are strictly necessary for the checksum calculation, you select your analytical framework, and you execute it with perfect notation. This is your definitive success blueprint for the hardest questions on the paper.
Let's do another quick challenge. Find the flaw. Never forget that presentation matters immensely. Following strict conventions ensures you don't leak easy marks on technicalities. If a student writes down, the computer adds up the random numbers to see if it's okay, you should instantly spot the flaw there. The terminology is completely wrong and far too colloquial. You must use exact syllabus terms. You would rewrite that fundamentally flawed sentence as, the system calculates a hash total by mathematically summing the customer ID fields to verify data integrity during batch processing. See how much more professional that sounds. You need clear annotations, proper headings, and appropriate formats. If the question explicitly asks for a table, draw a table. If it asks for an algorithm, structure it logically. Do not give the examiner an excuse to deduct marks.
Let's move to our final section. Section 4. Evaluation and Examiner Insights. Securing the highest assessment objectives.
This right here is the holy grail. The crucial takeaway is that examiners reward your logical journey just as much as your final destination. We call this the method mark strategy. Let's look at a realistic scenario. Say you are tasked with computing a really complex modulo 11 checksum for a product barcode. You're halfway through, you're feeling the pressure of the exam clock, and you make a simple, silly arithmetic error. If you just skipped the working and wrote down the final incorrect answer at the bottom of the page, you get 0 marks. But if you strategically laid out your headers, showed your rating factors clearly, documented the multiplication steps row by row, and explicitly stated the modulo division process, you will secure almost all the method marks available for that question, even with that final math error. The examiners desperately wants to see your thinking. They are assessing your procedural logic, not just your ability to punch numbers into a calculator.
If you're hunting for those higher-order marks, you must use this problem-solving triplet to compare alternative verification approaches and rigorously evaluate the limitations of your own evidence. Imagine another speed writing challenge. You have 30 seconds. A Cambridge command word asks you to evaluate whether a parity check or a checksum is better for a given scenario. First, you deconstruct the requirements. Let's say the scenario involves transmitting massive blocks of encrypted data over a very noisy, unreliable network. Next, you solve by briefly explaining how both methods would function in this environment. Then the absolute magic happens in step 3, evaluate. You must confidently justify that a simple parity check might be totally inadequate because it cannot detect an even number of transposed bits, whereas a checksum provides a much higher probability of detecting complex corruption. This triplet is exactly how you prove to the examiner that your analytical depth is stress-tested and robust.
We literally cannot stress this enough. Your perfect textbook knowledge of a hash total is entirely useless if you don't explicitly connect it to the specific scenario sitting right in front of you. Let's revisit Alex one last time. Alex writes, "A hash total is a meaningless sum of numbers used to check if data was entered correctly." Technically true, but contextually bankrupt. It's a weak answer. Now, if the exam scenario is about a massive retail bank processing nightly transactions, you must link it directly. You should write something like, "In this banking scenario, the system calculates a hash total by mathematically summing the routing numbers of all processed checks. Because routing numbers are not meant to be added for financial value, this acts as a verification method to ensure no checks were dropped or duplicated during the nightly batch processing." Do you see the massive difference? That second answer powerfully applies the Peel framework and binds the theory permanently to the context of the bank.
So, as we wrap up this system, I want you to look at the strategies we've built today. Command word decoding, the Peel framework application, and managing your time so you never rush a complex evaluation. As you prepare for your next paper, ask yourself how you will actively apply this method mark strategy to prove your absolute mastery of verification methods. Will you be like Alex, overwhelming the paper with raw, disconnected facts? Will you be like Sam, rushing and completely missing the command words? Or will you apply the standardized sequence to build an absolute masterpiece of an answer? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.